Now we turn our attention to acid-base balance, another part of chapter 15. In addition to being absolutely critical that we maintain normal body fluid concentration and osmolarity, it's also critical that we maintain body fluid pH. We've talked a little bit about a couple of mechanisms related to acid-base balance in our respiratory chapter and in our urinary system chapter on functions of the kidney. So, a couple of things. All of you have taken some introductory chemistry courses, so you should all know all of this, but as a brief review, we're talking here about the precise regulation of free hydrogen ions in our body fluids. Acids are substances which can dissociate from hydrogen ions when they go into solution. A strong acid has a greater tendency to release hydrogen ions than a weak acid. And bases are substances that can bind with free hydrogen ions and remove them from solution, where a strong base has a strong tendency to do that, and a weak base has a weaker tendency to do that. When we talk about pH, remember it's an inverse log scale of the concentration of hydrogen ions, of free hydrogen ions, where pH of 7 is neutral, a pH of less than 7 is acidic, and a pH of greater than 7 is basic or alkaline. So again, if we talk about strong acids versus weak acids, an example of a strong acid would be hydrochloric acid. And really, of course, the main place where we would find that in the body would be inside the stomach. But because each HCl molecule would dissociate from pretty much fully from its hydrogen ions, it's a strong acid because it releases all or nearly all of its hydrogen ions. By comparison, carbonic acid is a weak acid, and so you can see many of the carbonic acid molecules remain as carbonic acid, with only a few dissociating into bicarbonate and free hydrogen ions. So the number of free hydrogen ions here would be much greater, and thus we'd have a much lower pH here. And here we would have a smaller decrease in pH because there's only one free hydrogen ion. This is figure 15-5 in your text. So where do we typically find the pH of our body fluids? We're close to neutral, slightly on the alkaline side. On average, we're right around a pH of 7.4. And what range of pHs do we associate with our normal range? 7.35 to 7.45. And what range of pHs can we tolerate? Well, if we go below 6.8, we're going to have pHs that are incompatible with maintaining life. Perhaps there are some examples where in extreme muscle contraction inside some muscle cells you may temporarily drop slightly below that, but not much. And we can only do that for short amounts of time, and we cannot have extracellular fluid volume dropping below that point, certainly. And if we cannot tolerate pHs over 8.0 either. So if your blood pH, one thing that is challenging for students then is if our blood pH was 7.25, we would say that it is slightly alkaline, except that we would say the person is in a state of acidosis because their body fluids are more acidic than normal. So any pH below 7.35, we're going to say the person is experiencing some form of acidosis, either metabolic or respiratory acidosis. And if the body fluids are above 7.45, we'll say they're experiencing some form of alkalosis, like respiratory or metabolic alkalosis. I'll remind you that our venous blood carries more carbon dioxide and thus would have more carbonic acid and thus more hydrogen ions. And so venous blood is going to tend to be more acidic than arterial blood. And again, the pH is determined by the amount of free hydrogen ions, where on this end of the scale we have more free hydrogen ions, and on this end of the scale we have less free hydrogen ions, and or perhaps more free hydroxyl groups that can sequester hydrogen ions. That's figure 15-6. In summary, our normal range of pHs for body fluids is 7.35 to 7.45. The range of pHs compatible with life is 6.8 to 8. And any pH below 7.35, we would say the subject has some form of acidosis. and above 7.45 has some form of alkalosis. It's handy to try and make this relevant, students, to compare these to things that you'd find in your normal life. So, of course, our gastric fluids in the stomach would be very acidic at a pH of 1 to 3. Pepsin works best at a pH of 2, and so that works out fairly well. This is not 100% hydrochloric acid, owing for the fact that it's not the same as the pH for HCl. Lemon juice and many sodas would have a pH close to 2. Vinegar, wine, beer, and other citrus might be a little higher at 3. Tomatoes are fairly acidic, along with black coffee. Bread, typical rainwater. Urine, getting closer now to 7. Milk, a little bit on the acidic side of alkaline. Here we have pure water. Here we have blood. Egg whites are somewhat alkaline. Baking soda, phosphate detergents. Household ammonia being very basic. Hair remover, oven cleaner becoming even more basic. And sodium hydroxide being on the extreme end of alkaline or basic. So for acid-base balance, pHs less than 6.8 and greater than 8 are not compatible with life. We say that the person has acidosis at less than a pH of 7.35. Again, I'm going to stress that this is ironic to students because most students would associate acidosis with less than 7. But again, the term acidosis in the human body refers to the relative pH compared to our normal body fluids. And since the normal range of our body fluids is 7.35 to 7.45, anything below 7.35 would be considered acidosis. Alkalosis will be if the blood pH is greater than 7.45.